Right now, Potter, you can hijack. You can destroy everything. Nikki's happy.
Well, if Nikki's happy, then I'm happy. All right. So let me just move this and go over here. Okay, so can you see my screen? Is it this one?
See a giant screen. It's like you're sharing both of them, man. There you go.
Am I sharing both of them, or are you just saying that I have a huge screen?
You have a monstrous screen. I can see a code editor and I can see a HAX 70.
Okay, good.
Yeah.
That's what I want you to see.
Okay.
All right, so for the past couple of weeks, we've been showing the HAX integration with 11D, which is a static site generator. And so today what I wanted to do was sort of touch on the principles behind what a static site driven by web components and dynamic services could give you. So if you download HAX 11D and spin it up, you're going to get something like this. So it's just your normal static site with all of the assets being able to be zipped up and sent somewhere. All the configuration is saved, which is perfect. It's exactly what we want. So earlier, whenever we were talking about data permanence, this is pretty permanent. The fact that I can give you an entire site, all of its assets in a zip file, and it'll live on theoretically forever. That's a good thing. And on top of that, what we explored in the previous weeks was how to add web components, leveraging our CDN, leveraging that magic script that Brian showed, so that we can easily add web components just on demand from a CDN. So now what I wanted to talk about is the problem that you have with static sites and how web components could help. Is that, you know, traditionally we've all used CMSs, and with CMSs came functionality. So we were used to things like forms and login and image manipulation. That just came out of the box, right? Well, the static sites, we're getting a lot, but we're giving up a lot too. We're giving up functionality. So how can we make up that functionality? So how you might be able to overcome this problem with web components is the idea of doing a microservices approach. And if you approach it, if you're unfamiliar with microservices, it's just the basic concept of not having a monolith, which would be like your traditional WordPress, Drupal, traditional CMSs where there's a lot of functionality packed into one box. It's the idea that you would split those out into their discrete pieces, and that each of those, like the login functionality would be its own service, and the forms and the discussion boards would each be their own service. And you would stitch those together somehow to form a unified website or app. So that's what a microservice is. And I think that web components are a perfect way of stitching those experiences together. So let's take a look at what something like that might look like. So let's say that in this static site that we're using HAX 11D to create, it's for this IST class, and we want to teach our class some R code. So we create a page, and the page is just right here in this post directory. It's in this markdown file. And what I did was I just copied some HTML from this rexamples.com, and I posted it here in my IST course. Okay, let me bump that over again. So this is not bad. I could style these. I could use web components to style these, just like this site has, where you're presented with the actual R code that you would want to type out and compile. And on this example, they're showing us what the output would be for a server. We're going to take that approach and we're going to modify it a little bit. What we want to do is we want to put some functionality, some real deal functionality back into this website. What we want is to have an experience where the students can actually type out our code, manipulate the R code, and then process that code and get the result. Now, how can we do that? Well, we need to present an interface where they can type in. It's like a little coder area. And we also need something to process that. All right. So that's where the combination of web components and a dynamic backend service like Docker could come into play. So if web components is taking care of the front end user interaction of having the students type into a code editor, Docker could take care of processing that code and coming back with the result. So we have two things that we need to solve. So let's first solve the web component problem. So I'm going to replace these pre-tags that are just printing the code. I'm going to replace those with our rcoder tag. Now, rcoder is something that we made and built into our LRN web component CDN. And again, we had that magic script where if I just put the tag that our CDN knows about in our site, it will be auto-loaded, which is just fantastic. So there you go. So we've just solved that problem. So just like Nikki showed from her example of being able to, just with 2 lines of code, add it to our LMS, and all of a sudden all of our tags are available in our LMS. That's exactly what we've done here. So it looks like it's kind of working. We can type in it. So we can allow the students to type in it, but we can't process it, right? This is just what we're seeing here. The output is literally this piece here. So if I delete this example output, it's going to remove that. And we wanted this to be dynamic, right? So how might we do that? Well, this rcoder web component has a corresponding service called rservice. So what is rservice? Rservice is an R coding, is an R server, is an R environment that is wrapped up in a Docker image. So if you're unfamiliar with Docker, basically the idea of taking a snapshot, almost like a VM, a snapshot of a server, and packaging that up into what's known as an image, and you can then spin up containers based on that image. So if we have an rservice image, I could spin up 10 Docker containers that would be 10 servers, each running the rservice server on them. So it's pretty in the weeds, but just know that we can spin up a server on demand. So in this case, we are going to use Docker to spin up this rservice to go right along with our rcoder web component. So what I did is I ran, let me just bump that up a little bit. I ran this command, which is Docker run, and I'm gonna run my rservice container. And I'm just gonna expose it to a port so that our web component can talk to it. So how this image works, if we take a look at the README, is if we send it a chunk of R code, it should respond with whatever the output was from that server. So it's a pretty cool little server, little service. So let's link that up. So this is running on localhost port 3000. So I'm going to let my web component know exactly where its corresponding service is. So I do that. Now, whenever it refreshes, you see the process button is now, at first it was disabled, but now it's not. I can actually process this. So the web component is now hooked up to the backend. Okay. So again, we had the web component and we had the backend service. So these two pieces work in tandem to present this really high-end functionality to the static site. So now, instead of just printing, like this website was just printing the output here, we can actually process this dynamically, which means that I can now, as a student, change these variables. So 13 times 7, and I'm going to get a totally different answer here. So I can play around with that service. This is an extremely sophisticated little interaction here that with extremely minimal effort, we were able to put on this static site. So not only are we able to put it on the static site, we have, we're packaging up this functionality into our site that can now travel with our site, which is extremely important for open educational resources. And it's extremely important for like what we were talking about before with data permanence. I have a website. How do I ensure that it's going to live on forever? This is a way of breaking the services down, the functionality of what makes up a site, down into their discrete parts that will make it last a lot longer, because we can upgrade lots of aspects of our site. We could move it from a static site into a Drupal site. We could move it into an LMS, and yet this Uncoder service is going to function the exact same over time. So,
Boom.
boom.
Yeah, I wish Rick was here for the sustainability aspect of what that entails.
So this endpoint property, is that something that you could see managed via state management, so that you could just set it once globally for your site, and then any instance of our coder would just have the endpoint defined for our coder somewhere?
Yeah, exactly.
Nice.
And you know, that I think that's something that's definitely up for discussion on how best to do that. Because you know, with state management, these configurations, these settings live with the web component. So you wouldn't want the web component, this Uncoder web component, relying on a state management solution, right? So how can we apply these settings globally per, like on a per web component basis to our site?
Yeah, I think that kind of ties in with some of the settings I've just been ramming into global right now, where it's like, even if you look at the magic script, right, it just says like window dot underscore underscore app something or other, right? Which is part of the criticism with generally doing JavaScript in stuff that has access to Windows. It's the Wild West of everything in window. Yeah, there it is, that app CDN piece up there, and the force upgrade. And I recently started adding in like WC autoloader, like a whole string of things, so that you could, I ran into this issue with building locally versus deploying in a CDN. There's sometimes you have to manually define, because of the way our tooling works, and say like, hey, the base path is actually node underscore modules. Yeah, I wonder if there's any good, because you're not going to store that in a client, but you almost need a key pair type of a thing. And you don't want it to be heavy. Like it's probably just a convention we follow or something.
Yeah, right.
Didn't you sort of have something like that you were working on at one time, I thought, with like colors and...
Yeah. And I think it was just the some type of name convention of, it was like window dot settings dot the name of your element, and then, you know, an object.
Yeah, that might be a good other issue to file, Nikki, especially as you start kind of placing this in a system that's not directly within our control, which is different for sure from all the places that we keep demoing everything. We say like, hey, this can run anywhere, but yet we still do have control over it.
Well, and I was thinking too, from the idea of being able to take this stuff with you.
Mm-hmm.
Just the idea of, oh, I could take this site and prop it up, and
Yep.
portability aspect.
Yeah, exactly.
Cool stuff.
Yeah. So is it something that the CDN does for you? I don't know.
Yeah, I mean that's another possible way of handling it, right? I'm not saying it goes in the same file, but I mean it could. I mean, we're making up parts of these standards as we go. So, Will, are you there? You're paying attention?
Here, paying attention is always a conversation.
All right, there we go. Yeah. So, so with this this RCoder thing, like Mike's showing, and I'm not suggesting that you actually have any stat courses or whatever to teach R, but could you see a reason why it would be useful to drop that in and spin up functionality in anything you're working on?
We do have a couple courses that would work with, and frankly, anytime I've tried to look for tools like that, I'm going to somebody else's product, or you know, it's behind a paywall somewhere. So something like this that would be modular, and we could drop, if they can go into an LMS, or heck, just be accessible on a website at Penn State, something or other. That'd be fantastic.
We could get those lines into in our instance of Canvas.
I'll leave that on your door.
in Canvas, because it would need to be able to render HTML tags that are not the standard set, which they forcibly sanitize. So if they allow those to,
based on the CDN, or you know, based on that JSON file.
Yeah, I think we would need to do all of the work and put it in place ourselves, and then submit a PR, and then over 3 years, maybe they'll actually get around to integrating it.
Yeah, I mean, y'all are looking at these kinds of steps, and I'm just wondering how I'm going to get a new role in my node so that I can start to use the outcomes tool correctly. So, you know, I see different degrees of need, but similar processes involved.
Well, and I say that only because, like, what's the likelihood that just building all of the capabilities that we're on the course for, you throw these onto a static web page practically, and you let someone edit it, and you can replicate most of what Canvas is doing prior to going through their process to allow them to whitelist tags to allow us to do whatever we want.
Yeah, I was just thinking, you know, on our Penn State node, just the things that they were able to do just so that Evo could be iframed into a self-sizing iframe, and so that it could grab the table of contents from Evo. So I know it's possible, like on our end, without having to go through, you know, in structure.
It would be certainly worth something bringing up once you show some more examples.
Yeah, if only there were some World Campus people who had a new set of toys to play with that might be motivated.
That would be nice.
Maybe.
Nice.
A question for Mike.
Yeah.
So, I mean, like, containerizing and makes sense to me because you're overall saving resources and stuff like that. The kind of converse to this would just be buying some name brand server from a name brand company. But like an issue that like could happen is like resource management, right? So what if a student just like left this open and your R coder is still connected to your R service like backend,
Mhm.
like is there like a timeout function, or how do you manage that? Because I know that's without like getting like specific, but
Mhm.
it's like an issue with certain like applications and stuff like that, or certain departments have experienced in the past where um, there's just like a lack of resources and like students can't log in or they can't
Right.
actually like process our code because like too many resources are being left open on other devices, so like incoming students can't access those resources.
Right. Yeah. Yeah, that's a good point. So something like a similar project to, you know, the R coder thing was this containers on demand concept where um, so with the backend services, they're really split out into two separate categories. One is like just a one-off operation. Like I send you a call to do something, process this, resize this image, like send a notification, send a SMS text, email somebody. That's what's known as functions as a service, and there are frameworks out there that help you do that and in a very sustainable way. So they will help you with scaling issues. So that if 1,000 people want to process our code right now, it'll scale up your infrastructure to support that. The other piece that rarely gets talked about, but I think is something that education and OER really needs, is the notion of just containers on demand. So with functions as a service, everything is known as referred to as stateless, meaning that I don't have to, you know, remember who you are. I don't have to. I'm just doing one thing and then shutting myself down. Where something like what our students typically use, like Jupyter Hub to do their Python courses or their R Studio courses. These are things that are very stateful. So like doing an entire assignment in a Jupyter notebook. So I started a project called Containers on Demand to sort of solve that problem and to solve the problem that you just said. Like there's no reason why we should have to maintain an entire Jupyter Hub server for all of our students to connect to. That's a single point of failure. If nobody's using it, it's always running, you know. It's hard to configure on a per instructor level. Like with something like Jupyter Hub, you can have wildly different settings and configuration from one course to the next, that you need, you know, different libraries and everything. So by packaging that up into a Docker container, you'd be able to solve the configuration problem. You'd be able to solve the problem of multiple students connecting to it without the server going down constantly. Now there's definitely some, you know, it's not all magic. You need to know what you're doing. Like with something like OpenFOSS, you need to develop something like that would be able to start shutting down instances. I'm getting off into a little bit of a tangent, but yes, this is long story short, having the Docker infrastructure managing stuff like that, it would start to solve problems like you were referring to, Tom.
Yeah.
And Andrew knows much more about it than I do. So refer to all your Docker questions to Andrew.
Well, and the only thing that I was going to add, quite honestly, was just the fact that really what it comes down to is it's an issue of isolation more than it is efficiency. Because, I mean, yes, of course, if you are only running one thing on one server, it's not as efficient as if you were to run 10 things on that server. But the key thing that you're gaining out of containerization is the fact that, like Mike was saying, as far as the like the configuration, you can have 10 instances all configured completely differently, that if you tried to run them on the same server without containerization, then their settings would conflict. and it just wouldn't work. So that's one of the biggest things that containerization does for you. And then also the ability to start from a known zero state. If I go through and I change a whole bunch of stuff and it breaks everything, I can turn it off and turn it back on again, and I'm back to zero, and I can make my configuration changes again until I get it right.
Yep, and the web component can instruct the service to spin up different variants. So like if you need a Jupyter notebook with PyTorch for doing AI, that could be like an attribute that you set in a web component, as opposed to like using, I want a Jupyter environment just for writing Python, you know?
So then having like a timeout kind of feature would be unnecessary because the containers are processing each individual call versus like having just some like open server that's just like constantly running. Am I understanding that correctly?
Yes, sort of. Like you still need to handle the functionality of instructing the containers when would be appropriate to shut down. So I wouldn't want the container to shut down as soon as it loads like the initial response, because the student would then go to interact with it and hit, you know, process, and the container would be shut off already. So there is some decision making on how long should I keep this container active for. So for containers on demand, I think I have the option of either doing just letting it run for, I think they run for like 40 minutes at a time, or like session based, where it will remember your session ID that's stored in your browser, and it will associate that with a container. So the next time you come back, it'll reload that container. So yeah, so it's basically allows you a bunch of different possibilities depending on the experience that you're going for. I did make a video sort of going into this whole concept a little bit more in depth. I will post that in the chat.
Cool. So we're bumping up towards 5. Will or Nick, did you have anything you wanted to talk about, or else we'll just take it offline, which is perfectly fine as well.
I feel like everything was pretty clear. I'm good with like questions as far as now.